Basic idea that we need in this course from basic circuit theory is the idea of series and parallel. Now, once you see what it means to have components connected in series and what it means to have something connected in parallel, it's a pretty straightforward concept, but it takes a little while of looking at this and becoming familiar with the terminology. Okay, so I think the best way to approach it is to look at a couple of resistors connected into a circuit topology. All right, so I have a series topology showing up here where I have R1, here's resistor R1, here's resistor R2. And the key idea is that if resistors are connected in series, they have the exact same current, the same electrons running through them. Okay, so I can take a look here. Here's my current I. It would flow down this way and into this loop. It's the same electrons flowing through both R1 and R2. Notice that the voltage across R1 and R2 is not the same. Ohm's law applies. This says this is the voltage drop across R1 is V1, which is I times R1. So if you had a different value of R1 compared to R2, V2 would be a different value because it would be I times R2. All right, so the point is it's the current that's the same. What's different about parallel is it's the same voltage applied across both. So I have this voltage. If you make a loop here, we know that the voltage between A and B is V. So for parallel connections, it's the same voltage applied to each. So let's move on to the next thing I wanted to show you. The next thing I wanted to show you is let's talk about the points A and B. So I have here's point A and here's point B down here. And what I want to do is switch, instead of having resistors, let's put switches in. Okay, so the first switch would be here. I'll call this SW1. And the next switch would be here. These are connected in series, SW2. How do I know they're in series? Well, if you had current flowing through here, it'd be the same current flowing through both switches. All right. Okay, so what I want to do is look at when do you have continuity? By that I mean, when is there a wire that connects A and B without it being broken? All right, so the way this is shown now, both switch 1 and switch 2 are open, and so there's no path for current to flow between points A and B. All right, so I think it's fairly obvious that you get continuity, basically a wire, if and only if switch 1 is closed, and here's the important word, and switch 2 is closed. All right, so this AND operator, that's what lets us configure transistors in the right way to get the logic gate AND. All right, let's take a look over here with parallel. So with parallel, I have A and B, but instead of having a series path, I draw a parallel path. Okay. All right, I'll do it like that. Let me turn that up a little bit. All right, so I want to know what happens between A and B. Here's switch 1, here's switch 2. How do I get continuity? Well, I would have continuity, basically a wire connecting between A and B. Continuity, in this case, happens when switch 1 is closed or switch 2 is closed. So the parallel case gives you the logic function OR. All right, so we'll be using this to configure circuits using transistors to build up logic gates.